Welcome to our flipped classroom, where math knowledge makes things easier. Our objective today is that today I will be able to factor a variable expression. This is part of the 7.EE Common Core Curriculum Content Standards involving expressions and equations. Before we find factors, let's multiply two terms together. Say the terms 4 times x plus 5. If we look at it as a rectangle, length times width, this side, the width, is 4, and this side is x, and this part is 5, so x plus 5. Now, if we were to if we're going to multiply these two terms together, 4 times x, we'll simply get 4x. If we multiply the 4 times the 5, well, 4 times 5 is 20. So 4 times x plus 5, the product is going to be 4x plus 20. Let's take this a step further. If we know that we have the area of this big rectangle, both parts here, it's 10x plus 15. This part is 10x and this part is 15, so 10x plus 15. And we want to factor out a 5. One side is going to be 5. What's multiplied by that 5? That's going to give us a product, the area, of 10x plus 15. Length times width, we need to find, well, this is the width, and that's the length. We'll have to find the length. We already know the width is 5. So 5 times what term is going to give us 10x? Well, the 5 is here. I know I can multiply 5 times 2 to get 10, but the x isn't here with this 5, so the x has to be here with the other term. The other term would have to be 2x. 5 times 2x is 10x. What about the 15? If one factor is 5, the other factor, the other number multiplied by 5 to give me 15, is 3. 5 times 2x is 10x. 5 times 3 is 15. So I see if I multiply 5 times 2x plus 3, I would get a product of 10x plus 15. Let's look at another example. If I have 8x plus 36 as the area of this rectangle, remember the area of the rectangle is based on the length times the width. And I don't know what the length or the width is. Here's the length, here's the width. But looking at these two terms, I see that there is something I could factor out of both of them, a common factor. I know that they both end with even numbers, so 2 would go into each of them. 4 would go into each of them. Let's try working with 2. If one of the terms is 2, I know that 2 times 4 is 8, and I still have the x to deal with, so that's 4x. So 2 times 4x would give me 8x. And what times 2 would give me 36? Well, half of 36 is 18. So 2 times 18 is 36. So if I factored out a 2, the other factor would be 4x plus 18. So I could say that 2 times 4x plus 18 is going to result in 8x plus 36. What if I had factored out a 4 instead of a 2? Let's see what that looks like. There's my 8x plus 36, and I factor out a 4. Well, obviously, I'm not going to get a 4x here, because like I did with the 2, 2 times 4 is going to give me 8, but 4 times what is going to give me 8x? Well, obviously over here it's going to be 2x. And 4 goes into 36 9 times. So this other factor, if one factor is 4, the other factor is 2x plus 9. Well, that's all well and good, but then is what I'm saying that you could have different factors that would give me the same answer? Sure. We're saying that 4 times 2x plus 9 would give me 8x plus 36, but also that 2 times 4x plus 18 would give me 8x plus 36. There's no difference really in factoring algebraic terms and factoring regular numbers. you can have different factors. So remember your number trees from elementary school, your factor trees. Why don't you try one on your own? Check with me tomorrow, and if you could factor out more than one factor, remember, just because you might have a different factor than somebody else in class doesn't mean that you got it wrong. If you can prove that your two factors would give this product, then most likely you've got it right, and you understand how to factor a variable expression. So today, we were able to factor a variable expression. If you have any questions, ask me in class tomorrow. I'm looking forward